Hi everyone, welcome back to InnoScript. So let's solve today's LeetCode daily challenge, which is first missing positive. So let's read the problem statement first and then we'll see how are we going to solve it. So given an unsorted integer array in nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in O of n time, uses O of 1 auxiliary space. So it is mentioned in the question itself that we want to implement an algorithm that takes O of n time and O of 1 auxiliary space, right? So let's look at the very first example. It is 1, 2 and 0. So it says return the smallest positive integer that is not present. So smallest positive integer corresponding to size 3 is 1, 2 and 3, right? So 3 is missing, so we'll return 3. If we look at the second example, 3, 4, minus 1 and 1. The size of the array is 4. That means the smallest positive integer should be in the range of 1 to 4, right? So 1 is there. 2 is not present. That means 2 should be the answer. If we look at this example, 7, 8, 9, 11, 12 are present, but the smallest positive number that is missing is 1. So we'll return 1. Right? So I hope the problem statement is clear to everyone. Now let's look at one example and let's try to understand different approaches to solve this problem, and then we'll finally solve O of n time and O of 1 auxiliary space algorithm. So if I talk about this particular array, right, the size of the array is 8. That means the positive integers that should be present will be 1, 2, 3, 1 till 8, right? So 1 is already present, 2 is already present in the array, 3 is also present in the array, 4 is also present, 5 is also present, 6 is also present, 7 is not present. That means 7 should be the answer for this particular example, and again 8 is already present in the array, right? So now we know what the problem statement is. Now we'll try to understand different approaches. So approach 1 can be, so if you will try to look at this particular sequence, right, 1 till 8, and if I am writing 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1 up to 7 represent the indices and these are the numbers, right? So if I talk about the relation between the index and the number should be present at that particular index is, let's say index is 0. So index plus 1 should be equals to nums of index, So we can keep on checking this relationship between the index and the number present at that particular index, and if every index is satisfying this condition, that index plus 1 is equals to nums index. So we'll finally, if every index is satisfying this condition, we'll finally come at the last index, and whatever last number will be, we can return that, right? So if let's say if in this particular array, if 7 is present, let's say if minus, in place of minus 1, 7 is there, right? So our answer should be 9, because 1 till 8 all the numbers are present, then 9 is the smallest missing positive number, right? Since 7 is missing in this case, so answer should be 7, right? So one very basic approach which we can think of is, we will create a set of these numbers, right, and we'll start iterating from 1 till 8. Right, we'll create a set and we'll check whether 1 is present, condition true, 2 is present, condition true, 3 is present, condition true, 4 is present, condition true, 5 is present, 6 is present. But when we'll go and check for 7 is not present, and at that point we can simply return 7. And let's say all the numbers till 8 are present, we'll come out of the loop and again we'll return the same length of the array plus 1. Right. So first approach, we were creating a set, right, which will take O of n time, and we are iterating over each and every element till n, so it is again going to take O of n time, right? But question explicitly mentioned that we want to have an algorithm that takes O of n runtime plus O of 1 space, right? So let's try to understand that algorithm. So now let's look at another solution. Right, so we know that at every index, this particular index will hold index plus 1 value, right, index plus 1 value. So if we are talking about 0th index, this 0th index should hold 1, right, this 1 index should hold 2, this 2 index should hold 3, right, this 3 index should hold 4, this 4 should hold 5, 5 should hold 6, 6 should hold 7, and 7 should hold 8. Right, so this should be the sequence, right? So now let's try to look at the approach that how are we going to achieve this, right? So let's say I am starting from the 0th index. So at 0th index, my value is 3. And I know that this index should hold 1. but it is holding 3. That means this 3 should belong to some other index, right? So we'll check whether at this index, so this is corresponding to index 2, right? So we'll fetch the index. Let's try to fetch the index. How? Nums of I minus 1. This is going to give us index, right? So 3 minus 1 is going to give us 2. So we'll get 2. First of all, this index should be valid. What does it mean to be a valid index? It should be greater than equals to 0 and it should be less than the length of the array, right? If it is greater than equals to 0 and it is less than length, right, we'll say the index is valid, and at the same time we'll check whether the value at this index, which is nums of index, right, if it is not equals to the nums of I, right? So if the value at second index is not equals to 3, we'll make a swap, because this 3 should be at second index, right? So at this point, this second index does not hold the value corresponding to it, right? So it should have 3. So we'll make a swap. So what we are going to do, we'll swap these two values. So 3 will come at second index and minus 1 will go to 0th index, right? Now this is done. Let's move to the next index. So it might be possible that whatever value is being swapped, it is again not a correct value. So we cannot increment our ith pointer until we are sure that the value is at its correct position, right? So again we are going to do the same thing. What? Index, we are going to calculate the index. So minus 1, which is going to give us minus 2. So minus 2 is not valid. So in this case, we'll increment our pointer I, right? So now at this particular index, the value is 4. So corresponding to this 4, we are going to calculate the index. So 4 minus 1 is going to give us 3, right? So this 4 should be at 3, right? So first of all, this should be valid. So it is greater than equals to 0 and it is less than length. And we'll check whether at this particular index, at this 3, right? At this 3, so nums of index, if it is not equals to the current value, right? So if the value at this 3 is not equals to 4, we'll again make a swap. So let's make a swap. So 4 and 1. So 4 should come at this position and 1 should move to this position. So again we are not going to move our pointer because we are not sure whether this is, okay, this should be 1 and this should be 4. So this is 1, this is 4. So we'll not increment our I pointer because we are not sure whether the value we have placed at one index is at its correct position, right? So what we are going to do, we are going to do the same thing. We'll first calculate the index. So index will be 1 minus 1 will be 0. We'll go and check whether at this index the value is equals to 1. No. So we'll again make a switch, right? So we'll again make a switch. Let's make a switch. So now we are going to get minus 1 at one index, right? And 1 at its correct position, right? So we are at this point now and I is still pointing to this. So again, like before, we are not sure whether minus 1 is at its correct position. So we are again going to do the same thing. We are again going to calculate minus 1 which is going to give us minus 2. Minus 2 is not valid. So we'll increment our I pointer. Now we'll check whether at this index the value is same, right? Because we are going to get index as 2 and at this position, right, the value is 3 only, right? So we'll come to the next value. So again we are going to do the same thing. For 4 we are going to get 3 as an index and at this index 3, 4 is already there. So we'll move our pointer to the next one. Right now we are at 4. So when we are at 4, we are again going to calculate the index, right? So let's calculate the index. So 4, 2, again the index will be 2 minus 1, right, which is 1. So we'll go to 1 and we'll check whether 1 has 2 or not. So 1 doesn't have 2, so we'll again make a switch. So now 2 will come at this position, right? 2 will come at its correct position and minus 1 will move to 4. Right? But still we are not sure whether minus 1 is at its correct position or not. So we are going to do the same thing. Minus 1 we are going to get minus 2. So minus 2 is not valid. We'll move our I to the next one. So now we are at this position. So we are again going to calculate index. 8 minus 1 is going to give us 7. Right? 8 minus 1 is going to give us 7. We'll check whether the index is valid or not. So index is valid. We'll go to 7 and we'll check whether 7 has 8 or not. So 7 doesn't have 8, that means we are at this point need to make a switch or a swap, right? So we'll do 6 and we'll get 8 at this position, right? Again, we are not sure whether 6 at its correct position or not. So 6 minus 1 we are going to get 5, and at 5 position there is 6, so we don't need to do anything and we'll move our I pointer ahead, right? Again at 6 we are going to get index 4. 5 minus 1 will give us 4, right? We'll go to 4 and we'll check whether 4 has 5 or not. So 4 doesn't have 5, right? So we are again going to swap, right? So it will be having minus 1, and it is going to have 5, right? Now we are at 6. So we'll check whether minus 1, minus 2, it is not valid. We'll move our I pointer ahead, right? And we'll check whether this is a correct relationship. The condition will get true and we are at this. So our array will become this, right? Now we are going to find out which number is missing, right? So 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is not there. And how are we going to find it? We'll check whether index plus 1 is equals to the value at that particular index. So num's index. So if you will see, all the other indices are satisfying this condition other than this one. So at this point we are going to return 6 plus 1, which is nothing but index plus 1. And let's say if all the index satisfy this condition, we are going to return length plus 1, right? So let me write these steps. So first of all, what we are doing, we are calculating the index. At every index we are calculating one more index, which is nums of I, whatever value is there, minus 1, right? So if this index is valid, what we are going to do, at the same time, if this is valid, we will check whether the value at this index, is equals to the value which is at the ith, the current index, right? If this condition, if this is not true, let's say if this is not true, if they are not equal, that means we need to make a swap. So we'll make a swap with index and I, right? After that, if this condition is not getting true, we'll increment our I pointer by 1, right? And then finally we are going to check for each index, and whenever we found the answer or the conflict, we'll return that index, right? So in this case we didn't take any extra space, so space complexity is going to be O of 1, and we didn't take any extra space, so space complexity is O of 1 and the time complexity is O of n, because first we swap the indices and then we are checking for the correctness, right? So O of n plus O of n is going to give us O of n. So this is the space and the time complexity. So I hope you understood it. Now let's try to code it. So first of all, we'll be needing a swap function. So I am pasting the swap function here because I am hoping that you already know how to swap two numbers in the array. So I have written the swap function. Now what we are going to do, we are going to traverse each and every index. So I am initializing I is equals to 0. So when this I is less than nums.length, we are going to do something. What? First of all, we'll calculate the current index. How we were calculating? Whatever value is at the particular index, we were subtracting minus 1 from it, right? And now we were checking whether this index is valid. So index is valid when index is greater than equals to 0, and at the same time index should be less than nums.length. And we were also checking whether the value at this index, so nums index is equals to whatever is the value at ith position, right? So if these are not equal, if this value is not at its correct position, we are going to make a swap. So swap will be done index comma I, right? And if this condition is not true, we'll simply increment our I one position ahead, right? Now finally, after all this, what we are going to do, we'll iterate over each index and we'll see whether I plus 1 is equals to whatever is the value at that particular index, so nums of I, right? So if this condition is true, that means we are good to go, right? We'll keep on moving if this condition is getting true. But if they are not equal, at some point if they are not equal, if you remember in our example 7 was missing. So at the 6th index there was minus 1, right? So when we'll come to this 6, we'll check whether 6 plus 1 is equals to 7. So if it is not the case, 6 plus 1 is 7. If it is not equals to 7, in this case it is minus 1, we are going to return I plus 1, that 7 is missing number. And if every index is satisfying the relationship, we will come out of the loop and will return nums.length plus 1, right? So this is a code. Swap we already know. we'll keep on swapping until and unless the relationship is not getting true, right? And if this condition is not getting true, we'll simply increment our pointer. Otherwise, finally, after making all the swaps, we'll come out of the loop and we'll run another loop to check the relationship. If at any point the relationship is getting broken, we'll simply return I plus 1 from that point. Otherwise, we'll return nums.length plus 1 at the end, right? So I hope you understood it. This is not a hard problem, this is a logical problem. So if you were doing the questions consistently, right? So yesterday also the same kind of problem was there. So if you know the concept, you can easily solve this problem. So yeah, that's it for this video. Thank you.